The morning of June 4th, 1942 arrived with deceptive calm over the Central Pacific. The sun rose blood-red through wisps of cloud that hung motionless above waters so still they resembled polished glass. Commander Tamon Yamaguchi stood on the bridge of the aircraft carrier Hiryu, his binoculars trained on the horizon where American forces lurked somewhere beyond the curve of the earth. The smell of aviation fuel and salt spray filled his nostrils as he adjusted the focus, scanning methodically across the empty ocean. Behind him, the bridge crew moved with practiced efficiency, their voices low and confident as they prepared for the operation that would decide control of the Pacific. Japanese naval intelligence had briefed Yamaguchi thoroughly before the Midway operation. Their presentations delivered with the certainty of men who had spent months cataloguing every detail of American naval strength. The United States Pacific Fleet possessed exactly 4 operational aircraft carriers. The intelligence officers had laid out the evidence with meticulous precision. Lexington had been sunk at Coral Sea in early May, her massive hull settling into deep water after Japanese torpedo planes overwhelmed her defenses. Yorktown was reportedly damaged beyond immediate repair during that same engagement, bomb and torpedo hits, leaving her limping back toward Pearl Harbor with fires still smoldering in her hangar deck. That left Enterprise and Hornet definitely operational, both having participated in the audacious Doolittle raid on Tokyo just 6 weeks earlier. Saratoga might be available, intelligence suggested, though her exact status remained uncertain. And perhaps, if American damage control teams had worked miracles, Yorktown might somehow rejoin the fleet, despite the extensive damage she had sustained. 4 carriers, at maximum. More likely 3. The numbers had been verified through multiple intelligence sources, cross-referenced and confirmed through reconnaissance reports filed by operatives who had watched American naval movements from positions throughout the Hawaiian Islands. 4 carriers. Yamaguchi repeated the number to himself as he lowered his binoculars and turned to study the magnificent fleet arrayed behind Hiryu. The morning light gleamed off the flight decks of Akagi, Kaga, and Soryu, the 3 other carriers of his division. Beyond them steamed the fast carriers Shokaku and Zuikaku, the newest and most powerful vessels in the Imperial Navy. 6 fleet carriers against America's 4. 6 veteran ships whose air groups had destroyed the American battleship fleet at Pearl Harbor, sunk the British carriers Hermes and Cornwall, and dominated every naval engagement in the Pacific War's first 6 months. The mathematics seemed straightforward enough, as clear as the sun now climbing above the eastern horizon. Superior numbers, superior experience, superior aircraft, and the priceless advantage of the initiative would deliver another decisive victory that would force America to negotiate peace from a position of weakness. Admiral Yamamoto's plan called for drawing out the American carriers by threatening Midway, then destroying them through coordinated strikes from 6 directions simultaneously. The American ships would be overwhelmed, sunk, or crippled, leaving the Pacific an uncontested Japanese lake for years to come. Yamaguchi had studied the intelligence summaries with the careful attention of an officer whose life depended on accurate information. He had read the technical assessments of American shipbuilding capacity, the detailed analyses of construction timelines, and the projections of when replacement carriers might enter service. American shipyards operated under peacetime constraints that limited production to perhaps 1 or 2 carriers per year at maximum output. These were massive vessels displacing over 30,000 tons, requiring specialized facilities that could not be rapidly expanded even by a nation with America's industrial resources. The construction process itself demanded 30 to 40 months from keel laying to commissioning, a timeline dictated by the complexity of installing propulsion systems capable of driving 30,000 tons at speeds exceeding 30 knots, constructing armored flight decks capable of sustaining repeated aircraft operations, and integrating the thousands of systems required for these floating cities to function as combat vessels. The intelligence assessments noted that Newport News Shipbuilding had laid the keel for Essex, the first of a new carrier class, back in April 1941. But even with maximum priority and unlimited resources, Navy planners projected Essex would not commission until late 1943 at the earliest, perhaps mid-1944 if construction encountered the delays that seemed inevitable in such complex projects. The 4 carriers facing Japan at Midway, therefore, represented America's entire capacity for carrier operations in the Pacific for at least the next year, probably longer. They were a finite force that could be eliminated through bold action and superior tactics. Once these 4 vessels were sunk or crippled, America would lack the naval aviation capacity to contest Japanese control of the Western Pacific. The war would effectively be won, regardless of how long America might continue fighting from positions of strategic impotence. What Yamaguchi and every other Japanese naval officer standing on carrier bridges that morning failed to understand was that even as they steamed toward Midway with confidence born of apparently unassailable intelligence, the entire foundation of their strategic assumptions was crumbling in American shipyards they had never seen and could not imagine. At Newport News in Virginia, workers were already applying revolutionary construction techniques to Essex that would compress her construction timeline from 40 months to barely 17. The massive hull sections were being prefabricated simultaneously rather than sequentially, assembled using welding techniques that joined steel faster and stronger than traditional riveting could ever achieve. American intelligence had already photographed every detail of Essex's construction, tracking progress that was running months ahead of Japanese projections. The lead ship of a carrier class that would redefine naval aviation through mass production techniques borrowed directly from automobile assembly lines. Within 18 months, American shipyards would launch enough fleet carriers to outnumber Japan's entire carrier force, built over 2 decades of careful naval construction. The 4 carriers approaching Midway that morning were not America's maximum strength or even its total available strength. They were merely the peacetime fleet of a nation whose industrial capacity had not yet fully awakened to war's demands. But on that clear June morning, with the sun warming the teak decking beneath his boots and the smell of breakfast rice drifting up from the galleys below, Yamaguchi had no reason to question the intelligence that told him America possessed only 4 carriers. The numbers made sense. They aligned with everything Japanese doctrine taught about industrial capacity and construction timelines. They confirmed Japan's position of strength and justified the bold operation now unfolding across hundreds of miles of empty ocean. The American carriers were out there somewhere, steaming toward an ambush they could not escape, and a defeat that would end their nation's capacity to wage carrier warfare in the Pacific. Yamaguchi raised his binoculars again, scanning the horizon with renewed focus. Somewhere beyond that empty expanse of water, the 4 American carriers were moving into position. By nightfall, Japanese naval aviation would have sent them all to the bottom, and Japan's dominance of the Pacific would be secured for a generation. The mathematics were irrefutable. 6 carriers against 4, experience against desperation. Industrial might built over decades against a peacetime fleet stretched beyond its limits. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The conference room at Naval Intelligence Headquarters in Washington fell silent as Captain Edwin Layton spread reconnaissance photographs across the polished mahogany table. The images, grainy black and white prints, still smelling faintly of developing chemicals, had been taken by long-range patrol aircraft operating from Dutch Harbour in the Aleutians. They showed Japanese carrier formations steaming southeast with parade ground precision, their wakes arrow straight across a calm Pacific that appeared almost white in the high-altitude photography. Admiral Ernest King leaned forward over the table, his weathered hands spread flat on the wood as he studied each photograph with the intense focus of a commander who understood that the next 72 hours would determine whether America could maintain any meaningful presence in the Pacific or would be forced to retreat to a defensive perimeter along the California coast. The afternoon light slanted through tall windows, casting long shadows across maps that covered entire walls, red pins marking Japanese positions that seemed to stretch across half the world's surface. Staff officers stood at attention along the walls, their faces betraying the tension of men who had watched American defenses crumble for 6 months, while the Pacific became increasingly a Japanese lake. The air conditioning hummed softly but could not dispel the atmosphere of controlled desperation that had characterized these briefings since Pearl Harbor. King's staff had compiled detailed assessments of Japanese carrier strength that painted a sobering, almost hopeless picture: naval aviation imbalance. Japan operated 10 fleet carriers and at least 5 light carriers, a force of floating airfields that embarked experienced air groups trained to standards American squadrons could not begin to match. The pilots flying from Japanese carriers had honed their skills over years of conflict in China, perfecting coordinated strike tactics that American aviators had only read about in training manuals. Their aircraft, particularly the Zero fighter, had demonstrated performance characteristics that outclassed every American carrier fighter currently in service. The attack on Pearl Harbor had demonstrated Japanese tactical superiority in carrier operations with devastating clarity. The coordinated strike that had crippled the Pacific Fleet battleship force had been executed with precision that American observers found difficult to comprehend. 6 carriers launching over 350 aircraft in 2 waves, achieving complete tactical surprise, and retiring, without losses that significantly degraded their striking power. The operation had been a masterpiece of naval aviation planning and execution. Subsequent victories at Ceylon and throughout the Indian Ocean had confirmed Japanese dominance over even the Royal Navy's carrier forces, vessels operated by sailors who had ruled the world's oceans for 3 centuries. The British carriers Hermes and Cornwall had been sent to the bottom by Japanese carrier aircraft that had overwhelmed their defences. Through coordinated attacks, the British had no effective means of countering. If the Imperial Japanese Navy could destroy British carriers operated by experienced crews, what hope did America's partially trained squadrons have against the same enemy? Against this formidable carrier force, America could deploy exactly 4 fleet carriers to defend Midway. Enterprise and Hornet had been rushed back from the Doolittle raid on Tokyo, their crews exhausted from continuous operations, but their aircraft and equipment still operational. Yorktown had limped into Pearl Harbor after the Battle of Coral Sea, with bomb damage that Navy estimates suggested would require 3 months of shipyard repairs to make her combat-ready again. Commander John Ford watched Yorktown limp into Pearl Harbor on the afternoon of May 27th, her flight decks scarred by bomb craters hastily patched with wooden planking, her hull riding low in the water from flooding that damage control teams had been fighting for days. The famous Hollywood director had volunteered for Navy service as a photographer, and he stood on the dock with his camera, filming the battered carrier's arrival with professional detachment that masked genuine shock at the extent of her damage. Through his viewfinder, he could see sailors on her decks, moving with the exhausted shuffle of men who had not slept properly in a week, their uniforms stained with oil and smoke residue that no amount of washing could remove. The smell reached the dock before the ship did. Burned electrical insulation, scorched paint, the acrid stench of firefighting foam, and beneath it all the sickly sweet odor of fuel oil leaking from ruptured tanks deep in her hull. Black smoke stains marked where fires had been fought and extinguished, only to reignite hours later from smouldering insulation hidden behind bulkheads. Her hull plating showed the unmistakable dimpling where Japanese bombs had struck. Their explosive force transmitted through steel, thick enough to stop rifle bullets but thin as paper against weapons designed to penetrate ship armor. Navy damage control experts swarmed over Yorktown before her mooring lines were even secured, their faces grim as they catalogued the extent of repairs that would normally require months of careful shipyard work. The carrier's commanding officer, Captain Elliot Buckmaster, met them at the gangway with detailed damage reports compiled during the desperate voyage back from Coral Sea. 3 bombs had struck during the battle, one penetrating deep into the ship before exploding near engineering spaces, killing or wounding dozens of men and rupturing steam lines that fed propulsion turbines. Near misses had opened seams in her hull plating below the waterline, allowing slow flooding that pumps could barely control. The assessment teams delivered their preliminary reports by early evening. Under normal circumstances, Yorktown would require 90 days minimum in dry dock for proper repairs. The bomb damage alone demanded replacement of structural members, repellating of damaged hull sections, and complete rewiring of electrical systems that had been shorted out by firefighting water. The flooding had damaged her propulsion systems in ways that would require pulling turbines for detailed inspection and possible rebuilding. Her anti-aircraft batteries needed replacement, where fire had warped gun barrels beyond safe use. Her flight deck required complete resurfacing, where wooden planking covered bomb craters that made certain areas too weak for aircraft operations. Admiral Nimitz listened to these reports in his Pearl Harbor headquarters, then delivered instructions that left the damage control officers staring in disbelief. Yorktown would be made seaworthy in 72 hours, not fully repaired, not restored to pre-war condition, but capable of steaming at combat speed and operating aircraft, even if only at reduced capacity. Every civilian yard worker in Honolulu would be mobilized. Every Navy repair crew not already committed to other critical work would report to the dry dock. Work would proceed around the clock under floodlights that would turn night into day. The Japanese were coming to Midway, and America needed every carrier that could possibly be made to float and fight. The decision reflected American naval strategy's desperate situation in late May 1942. Losing even one carrier from America's tiny force would leave. Only 3 operational flat tops in the entire Pacific, insufficient numbers to contest Japanese naval dominance or support the defensive operations that American strategy required. Every available carrier had to fight at Midway regardless of their condition or state of crew readiness. A damaged carrier that might founder from her wounds was preferable to no carrier at all, given the strategic calculus facing American planners. Over the next 72 hours, Pearl Harbor transformed into a scene that could have come from Kaiser's revolutionary Liberty shipyards. 1,400 civilian workers poured through Yorktown's hatches in shifts that never ended, welders and electricians and damage control specialists working side by side in spaces so cramped they had to coordinate their breathing. The air inside reeked of cutting torch smoke and fresh paint applied over surfaces not yet properly prepared. Sparks from welding equipment showered down onto workers laboring on decks below, who learned to work under improvised shields that protected them from the glowing metal rain. Welders patched hull plating with plates cut and fitted in hours rather than days, their welds inspected through quick visual checks rather than the careful X-ray examination that peacetime standards demanded. The repairs would never pass formal Navy inspection, but they would keep water out long enough for Yorktown to fight one more battle. Electricians rewired damaged systems using whatever cables were available in Pearl Harbor's depleted supply dumps, running temporary lines that bypassed destroyed junction boxes and creating electrical distribution networks that bore only passing resemblance to the carrier's original design specifications. The flight deck received particular attention because without a functioning flight deck, Yorktown would be useless regardless of her ability to steam. Damaged sections were cut away entirely and replaced with fresh teak planking that still smelled of sawdust and raw wood. The replacement planking came from supply stocks intended for pier construction, heavier and harder than the specialized deck material normally used, but it would support aircraft weight, and that was all that mattered. Arresting cables were inspected and replaced, where fire damage had weakened the braided steel. Aircraft elevators received enough repair to function, even if the mechanisms groaned and shuddered under loads they had once lifted smoothly. At 4 a.m. on May 30th, just 70 hours after entering dry dock, Yorktown's propulsion systems came back online with a rumble that shook the entire vessel. Engineers watched pressure gauges and temperature readouts with prayers as much as technical expertise, knowing that the hasty repairs might fail catastrophically once full power was demanded. But the turbines held. Steam flowed through hastily patched lines without rupturing. The massive bronze propellers bit into Pearl Harbor's waters and drove the porous, 30,000-ton hull forward despite damage that by rights should have kept her immobilized for months. Yorktown departed Pearl Harbor on May 30th, just 72 hours after entering dry dock, her crew amazed and somewhat terrified that the massive vessel had been made seaworthy through sheer force of American industrial determination. Captain Buckmaster knew the repairs were temporary at best. His engineers had warned him that the turbine repairs might fail at any moment, that the hull patches might open under combat stress, that a dozen critical systems were held together with improvisation and prayers. But temporary was enough. Yorktown would steam to Midway. She would fight, and if she sank afterward, at least she would not be sitting helplessly in port while the battle that would determine the Pacific War's outcome was fought without her. The three American carriers that sortied toward Midway in early June 1942 represented America's entire capacity for offensive carrier operations in the Pacific theater. Not its desired force, not even its minimum adequate force, but every carrier that could possibly be made ready for combat in the time available. Enterprise and Hornet operated as Task Force 16 under Admiral Raymond Spruance, an officer promoted to carrier command despite having no previous experience with carrier operations because the Navy simply lacked enough carrier-qualified admirals. Yorktown formed Task Force 17 under Admiral Frank Fletcher, her crew still discovering failures in the hasty Pearl Harbor repairs as they steamed westward. The division into two task forces reflected tactical necessity rather than strategic preference. America lacked the escorts, the supply ships, and the command structure to operate three carriers as a single, unified force. The Navy was learning carrier warfare while fighting for survival, improvising tactics and procedures that Japan's Navy had refined over years of deliberate preparation. American carrier doctrine barely existed beyond a few tentative training manuals, written by officers whose theoretical understanding of carrier warfare had been shattered by Japanese tactical excellence at Pearl Harbor. The real transformation, however, was occurring at the Newport News shipbuilding facility, where Essex was taking shape, using construction techniques that prioritized speed over traditional craftsmanship. The shipyard had reorganized its workforce into specialized teams that prefabricated major hull sections simultaneously, rather than building the vessel sequentially from keel to flight deck. Welding had largely replaced riveting, allowing faster assembly while creating hulls that could better withstand battle damage through improved structural integrity. These innovations remained invisible to Japanese intelligence analysts, who based their assessments on traditional construction timelines that assumed American carriers would continue requiring 3 to 4 years from keel laying to commissioning. The concept that American industry might apply mass production techniques to carrier construction seemed as unlikely as the idea that aircraft as complex as bombers could be built on assembly lines in quantities that exceeded entire nations' industrial output. Admiral Isoroku Yamamoto had planned the Midway operation based on intelligence assessments that treated America's 4 carriers as a finite force that could be eliminated through decisive action. His staff had calculated that sinking 2 or 3 American carriers would force the United States to abandon offensive operations for at least a year while their shipyards completed vessels already under construction. The plan assumed that carrier losses would be strategically decisive because American industrial capacity could not rapidly replace these complex vessels. The Battle of Midway would prove Yamamoto's tactical assumptions partially correct. American carriers did prove vulnerable to coordinated Japanese strikes when those strikes could penetrate defensive fighter screens. But the strategic assumption that America possessed only 4 replaceable carriers would be shattered within months, as American shipyards demonstrated production capabilities that Japanese planners had dismissed as impossible. Commander Ford watched Yorktown limp into Pearl Harbor on May 27th, her flight deck scarred by bomb damage, and her hull taking on water through compromised plating that would normally require months of careful repair work. Navy damage control experts swarmed over the carrier, assessing whether she could possibly be made seaworthy in time for the battle that intelligence indicated would occur within a week. The decision to attempt 72-hour emergency repairs on Yorktown reflected American naval strategy's desperate situation in late May 1942. Losing even 1 carrier would leave America with only 3 operational flat tops in the Pacific, a force insufficient to contest Japanese naval dominance or support the offensive operations that American strategy required. Every available carrier had to fight at Midway regardless of their condition or crew readiness. Over 1,400 civilian workers joined Navy repair crews in a round-the-clock effort that transformed Pearl Harbor's dry docks into something resembling Kaiser's revolutionary shipyards. Welders worked in shifts that never stopped, patching hull plating and reinforcing damaged structural members with temporary repairs that would never pass peacetime inspection standards. Electricians rewired damaged systems using whatever materials were available, prioritizing functionality over adherence to design specifications. The flight deck received enough patching to operate aircraft, though portions remained weakened by fire damage that made certain areas unsafe for sustained operations. Yorktown departed Pearl Harbor on May 30th, just 72 hours after entering dry dock, her crew amazed that the massive vessel had been made seaworthy through sheer force of American industrial will. The repairs would never have been attempted under peacetime conditions, but war had transformed acceptable risk calculations. A partially repaired carrier that might sink from her damage was preferable to no carrier at all, given the strategic situation facing American forces. The 3 American carriers that sortied toward Midway in early June 1942 represented America's entire capacity for offensive carrier operations in the Pacific Theater. Enterprise and Hornet operated as a combined task force under Admiral Raymond Spruance, while Yorktown formed a separate force under Admiral Frank Fletcher. The division reflected tactical necessity rather than strategic preference. America simply lacked sufficient carriers to form the multi-carrier task forces that would later characterize Pacific operations. Japanese reconnaissance. Aircraft that shadowed American forces toward Midway counted exactly what their intelligence had predicted. 3 carriers, possibly 4, if Yorktown's presence could be confirmed through additional sightings. The numbers matched intelligence assessments perfectly, confirming Japanese assumptions about American carrier strength and reinforcing confidence that the Midway operation would succeed in eliminating America's Pacific Fleet carrier aviation capability. What Japanese reconnaissance failed to detect were the industrial facilities already transforming American carrier construction from a slow peacetime process into a wartime production program that would launch vessels at rates Japanese planners considered impossible. At Newport News, Essex's hull was taking shape with speed that amazed even experienced shipyard workers. Major sections that traditionally required sequential construction were being assembled simultaneously using prefabrication techniques that allowed parallel workflow impossible under conventional construction methods. The Battle of Midway opened at dawn on June 4th, with Japanese strike aircraft roaring off carrier decks into a sky that promised perfect flying weather. Commander Yamaguchi stood on Hiryu's bridge, watching the first wave of bombers and fighters climb toward altitude before turning southeast toward Midway Atoll, their engines' drone fading to a distant hum that reminded him of summer insects over rice paddies. Behind him, flight deck crews were already spotting the second-wave aircraft, pushing Zeros and Kates into position for the follow-up strike that would finish whatever the first wave left standing. Confidence pervaded every level of the Japanese carrier force. The pilots departing for Midway were veterans of Pearl Harbor, Ceylon, and a dozen other victories. They flew aircraft superior to anything America possessed and employed tactics refined through years of actual combat experience. Their formations showed the precision of units that had trained together until coordination became instinct. Each pilot, knowing exactly where his wingmen would be without needing to look, trusting in skills that had been proven repeatedly against enemies who had learned too late the cost of facing Japanese naval aviation. American torpedo bombers appeared first, lumbering Douglas Devastators struggling to reach attack position against a sky suddenly filled with Zeros that fell on them like hunting eagles. Yamaguchi watched through binoculars as the American attack unfolded with tragic predictability. The Devastators, obsolete aircraft that should never have been sent against modern carrier forces, pressed their attacks with suicidal courage that Japanese pilots would later describe with genuine respect. But courage alone could not compensate for aircraft that were too slow, too poorly armed, and flown by pilots whose training had not prepared them for the reality of combat against Japan's elite naval aviators. From all three American carriers, torpedo bombers attacked in waves that were slaughtered almost to the last aircraft. Zeros tore through the plodding American formations, their 20mm cannons shredding fabric control surfaces and puncturing fuel tanks that exploded into orange fireballs. The few Devastators that survived the fighter attacks pressed on into anti-aircraft fire so dense it formed visible curtains of shell bursts and tracer streams. Some launched their torpedoes from ranges so great the weapons had no chance of hitting their targets. Others bored in close enough to see Japanese sailors on carrier decks before being blown apart by direct hits. Of 41 Devastator torpedo bombers launched from Enterprise, Hornet, and Yorktown that morning, only 6 would survive to return to their carriers. The massacre confirmed every Japanese assumption about American tactical inferiority. Their own air groups had lost handfuls of aircraft to similar attacks during training exercises that simulated far more competent opposition than these Americans had demonstrated. Japanese carriers maneuvered freely, their crews supremely confident that American forces lacked the coordination, the skill, and the weapons to penetrate defenses that had proven impenetrable against better-equipped enemies. Yamaguchi stood on his bridge, watching smoke trails from downed American aircraft dissipating in the morning wind, feeling the satisfaction of a professional watching amateurs make exactly the mistakes that professionals had predicted. Then a lookout's shout drew his attention skyward, and the world transformed with a violence that would haunt his final hours. At 10:26, precisely 6 minutes that would change naval warfare forever began unfolding across the clear Pacific sky. American dive bombers from Enterprise and Yorktown appeared almost directly overhead, their arrival timed by accident and desperation to coincide with the exact moment when Japanese flight decks were crowded with aircraft being rearmed and refueled. The timing was not the product of brilliant American coordination. It was pure chance combined with Japanese tactical mistakes that had left their combat air patrol out of position and their carriers vulnerable at exactly the wrong moment. The dive bombers rolled into their attacks from 17,000 feet, plummeting almost vertically toward targets that suddenly appeared helpless despite their massive size and powerful defenses. Yamaguchi watched Akagi, the flagship, take a bomb hit near her midships aircraft elevator. The explosion's flash followed seconds later by secondary detonations as gasoline and ordnance ignited on the hangar deck. Another bomb struck moments later, and another, each hit triggering more fires that raced through the carrier with terrifying speed. Kaga took multiple hits almost simultaneously, bombs penetrating her flight deck and exploding in confined spaces where their blast effects were magnified beyond anything their designers had intended. Within 90 seconds, the carrier that had been the pride of the Imperial Navy was transformed into a floating funeral pyre, her flight deck buckled by internal explosions, her crew struggling hopelessly against fires that consumed oxygen faster than damage control teams could respond. Hiryu staggered under her own bomb hits, 3 direct strikes in rapid succession that turned her flight deck into a charnel house of burning aircraft and dying men. From Hiryu's bridge, Yamaguchi could see all 3 carriers burning, columns of black smoke rising thousands of feet into air that had been clear moments before. The smell of burning fuel oil and explosives reached Hiryu within minutes, carried by winds that seemed to mock the neat tactical plans that had brought the Japanese carriers to this position. Within 6 minutes, 3 Japanese fleet carriers had been crippled by attacks that should never have succeeded, if any. Single element of Japanese tactical planning had functioned as intended, but the attacks had succeeded through a combination of American desperation and Japanese overconfidence that had left critical gaps in defensive coverage at precisely the moment when American dive bombers reached attack position. Yamaguchi watched the 3 carriers burning and felt his confidence shaken but not destroyed. Hiryu remained operational, with a full strike force, ready for immediate launch. The tactical situation remained manageable, barely, if Hiryu could strike quickly enough to cripple American carriers before they recovered from their strike. Japanese training emphasized aggressive counterattack as the proper response to crisis. Yamaguchi would demonstrate that doctrine's validity by destroying American carriers, even as his own force burned around him. He gave the orders that sent Hiryu's strike aircraft toward the American carriers, knowing that Japan's carrier war in the Pacific now depended entirely on his ship and his air group's ability to achieve what 3 other carriers had failed to do. Hiryu's aircraft located and attacked Yorktown at midday, landing bomb and torpedo hits that should have sunk any carrier built to less robust standards. But American damage control parties fought the fires and flooding with skills honed through continuous training that emphasized survival over abandonment. Yorktown remained afloat, though dead in the water, her crew working frantically to restore power and resume operations. The afternoon strike from Hiryu found Yorktown again, landing additional torpedo hits that doomed the carrier despite heroic damage control efforts. Japanese pilots reported to Yamaguchi that they had destroyed 2 American carriers, unaware they had struck the same vessel twice due to American damage control effectiveness that had restored Yorktown to operational appearance between strikes. American search aircraft located Hiryu late that afternoon, vectoring dive bombers from Enterprise to attack the last surviving Japanese carrier before sunset. Bombs struck Hiryu's flight deck and hangar spaces, igniting fires that quickly spread beyond control despite Japanese damage control efforts. By evening, all 4 Japanese carriers that had attacked Pearl Harbor were burning or sinking, victims of tactical mistakes and coordination failures that American forces had exploited with devastating effectiveness. Commander Yamaguchi remained on Hiryu's bridge as the carrier settled into the Pacific, his confidence in Japanese carrier superiority shattered by a battle that demonstrated American tactical skills had evolved far beyond Japanese intelligence assessments. But even in defeat, Yamaguchi never questioned the fundamental assumption that America possessed only 4 carriers capable of Pacific operations. The intelligence briefings had been clear. These 4 vessels represented America's maximum carrier strength for at least the next year. What Yamaguchi could not know as Hiryu's hull disappeared beneath the waves was that American shipyards had already begun production runs that would launch Essex in less than 14 months. The 4 carriers at Midway were not America's total strength. They were merely the advance guard of an industrial mobilization that would produce fleet carriers faster than Japan could train crews to oppose them. The victory at Midway shattered Japanese carrier aviation's tactical superiority, but the strategic consequences extended far beyond the immediate battle results. Japan had lost 4 fleet carriers, whose construction had required years of specialized shipyard work by craftsmen trained through decades of naval building experience. America had lost Yorktown, a vessel whose destruction had been anticipated before the battle, given her damaged condition and the desperate repairs that had made her barely seaworthy. The loss ratios seemed to favor America: 4 Japanese carriers for 1 American flat-top, but the deeper implications involved industrial capacity rather than simple vessel counts. Japan could not rapidly replace the 4 carriers sunk at Midway because Japanese shipyards lacked the capacity for simultaneous construction of multiple fleet carriers using traditional building methods. American shipyards were about to demonstrate that carrier construction could be transformed into a mass production enterprise using techniques that would have seemed impossible to naval architects trained in conventional shipbuilding. Crafts. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The telegram that reached Newport News Shipbuilding on June 7, 1942, carried instructions that would transform naval construction as thoroughly as Midway had transformed naval tactics. William Francis Gibbs, the naval architect whose designs had revolutionized merchant ship construction, stood in the shipyard superintendent's office, reading the Navy Department's message for the 3rd time, his engineer's mind already racing through the implications. Accelerate Essex completion by any means necessary. Authorization granted for departure from standard construction procedures. Maximum priority for material allocation. The message's bureaucratic language masked a simple reality. America needed carriers faster than any navy in history had ever built them, and conventional methods would not suffice. The shipyard that morning hummed with activity that would have seemed chaotic to peacetime observers, but represented carefully orchestrated industrial symphony to men who understood modern construction techniques. Essex's massive hull stretched across the building way, her bones already taking recognizable shape despite being months away from completion by traditional standards. Steel plates awaited installation, sections of her hangar deck sat in, assembly jigs, and her propulsion turbines rested in protective cocoons, awaiting the moment when they would be lowered into engineering spaces not yet fully constructed. Traditional carrier construction followed sequences as rigid as religious ritual. The keel was laid first, a massive spine of structural steel onto which frames would be attached in careful succession from bow to stern. Once the frames achieved sufficient height and rigidity, hull plating would be riveted onto the framework, starting at the keel and working outward and upward until the hull achieved watertight integrity. Only after the hull was substantially complete would workers begin installing internal components, working from bottom to top in sequences that ensured each level was finished before construction commenced on spaces above. The process demanded skilled craftsmen who had learned their trades through years of apprenticeship, riveters who could drive glowing metal fasteners through steel plate with precision measured in fractions of inches, pipe fitters who understood how to route steam lines, fuel lines, and water lines through spaces so cramped that blueprints often failed to convey the actual installation challenges, electricians who could decipher wiring diagrams showing thousands of circuits running through hundreds of miles of cable, connecting every system aboard a floating city designed to survive enemy action that would sink any merchant vessel. The timeline for such construction reflected its complexity. Yorktown's builders had required 40 months from keel laying to commissioning, 40 months of careful work during which each phase was completed and inspected before subsequent work commenced. Essex, laid down in April 1941 using similar methods, had been projected for completion in mid to late 1943, perhaps 30 months if everything proceeded perfectly. But perfection had become a luxury America could no longer afford. Essex needed to commission within months, not years, and that demanded construction methods that would have horrified peacetime naval architects. William McDowell, the shipyard superintendent responsible for Essex's construction, stood before his assembled section chiefs that afternoon, delivering instructions that rewrote decades of shipbuilding wisdom. The carrier would be built in sections. Major hull components would be prefabricated at work areas throughout the yard, then assembled like pieces of a massive puzzle using cranes powerful enough to lift sections weighing hundreds of tons. Welding would replace riveting wherever possible, creating joints that were stronger, faster, and required less skill to complete successfully. Systems installations would proceed in parallel rather than sequence, with teams working simultaneously in different areas of the ship, despite the coordination challenges such parallel workflow created. The transformation extended beyond construction techniques to encompass every aspect of shipyard operations. New workers flooded into Newport News from surrounding counties, men and women whose only qualification was willingness to learn and ability to follow instructions. The shipyard established training programs that compressed years of traditional apprenticeship into weeks of focused instruction on specific tasks. A worker did not need to understand every aspect of naval construction to learn how to operate a particular welding technique or install a specific type of pipe fitting. Mass production required specialized skills, not universal craftsmen. Essex's hull was divided into major modules designated by numbers and colors that covered blueprint pages pinned to walls throughout the yard. Section 12, painted red on the plans, comprised her forward hull from the stem to the first major transverse bulkhead. Section 23, in blue, formed her engineering spaces, where turbines would drive propeller shafts capable of pushing 30,000 tons through ocean waters at speeds exceeding 33 knots. Each section was assigned its own work area where teams could labor without interfering with adjacent sections still taking shape. The prefabrication approach allowed truly parallel construction that had never been attempted with vessels of Essex's size and complexity. While Section 12's frames were being welded together in Assembly Bay 3, Section 23's hull plates were being fitted in Bay 7. Flight deck components were taking shape in dedicated facilities where specialized teams had perfected techniques for creating the armored deck structure that had to support aircraft weighing over 10 tons while remaining light enough not to make the carrier dangerously top-heavy. Welding replaced riveting in a transformation that changed not just construction speed, but the fundamental nature of ship hulls. Traditional riveting required teams of skilled workers driving glowing steel rivets through aligned holes in overlapping plates, each rivet requiring multiple hammer blows to form the mushroom head that secured the fastener. A good riveting team might install 50 rivets per hour, exhausting work that produced joints adequate for peacetime service, but prone to failure under combat damage that could unzip entire seams as individual rivets failed. Electric arc welding created continuous joints stronger than the plates they connected, fusing steel at molecular level through carefully controlled application of heat that melted base metal and filler rod into homogeneous unions. A skilled welder could lay feet of weld bead per hour, creating joints that would not fail catastrophically even when damaged, because the continuous bead lacked the discrete failure points that characterized riveted construction. More significantly, welding required weeks rather than years to master, allowing rapid training of workers whose only previous experience might have been farm labor or factory work. The revolution in construction speed showed results by late summer 1942. Essex's projected commissioning date moved forward from mid-1944 to December 1942, an acceleration of 18 months achieved through industrial techniques that traditional naval architects had dismissed as impossible for vessels of such complexity. The hull sections came together with precision that amazed even experienced shipyard workers, massive pieces lifted by cranes and positioned so accurately that weld seams could be completed without the extensive grinding and fitting that riveted construction required. Essex's hull was divided into major modules that were constructed at separate work areas before being assembled into the complete vessel using massive cranes and welding techniques that joined sections with speed impossible using traditional riveting methods. The flight deck, traditionally one of the last major structures added during carrier construction, was pre-built in sections that could be installed rapidly once the hull reached appropriate completion stage. Engine rooms and propulsion systems were assembled as complete units that could be lowered into the hull rather than being built in place through labor-intensive installation of individual components. The transformation required complete reorganization of shipyard workflow and retraining of workers accustomed to traditional construction methods. Welders who had spent careers working with riveting techniques learned to join massive steel plates using electric arc welding that created joints stronger and faster than riveted connections. Crane operators mastered techniques for positioning hull sections weighing hundreds of tons with precision measured in fractions of inches. Assembly teams developed coordination skills that allowed them to work simultaneously on multiple sections without interfering with adjacent work crews. The results began appearing in production schedules by late summer 1942. Essex's projected commissioning date moved forward from mid-1944 to December 1942, a compression of 18 months achieved through industrial techniques that had never been applied to carrier construction. More significantly, the lessons learned from Essex's accelerated construction could be applied to subsequent vessels in the class, creating a production pipeline that would eventually launch fleet carriers at intervals of less than 3 months. Japanese naval intelligence remained unaware of these developments through the summer and fall of 1942. Their assessments of American carrier strength continued to project that replacement vessels would not enter service until late 1943 at earliest, giving Japan nearly 18 months to consolidate their defensive perimeter and prepare for renewed American offensive operations. The intelligence failure reflected fundamental misunderstandings about American industrial capacity's ability to adapt peacetime construction methods to wartime production requirements. Admiral Yamamoto reviewed his staff's intelligence summaries in August 1942, noting with satisfaction that American carrier strength in the Pacific remained limited to 3 operational flat tops, following Yorktown's loss at Midway. Enterprise had sustained bomb damage during operations near Guadalcanal, temporarily reducing American carrier strength to just 2 vessels available for immediate operations. The numbers suggested Japan retained strategic advantages despite Midway's tactical defeat, provided Japanese forces could avoid additional carrier losses, while American shipyards slowly completed replacement vessels. The Battle of Santa Cruz in October 1942 appeared to confirm Japanese strategic assessments. Hornet was sunk by combined air and surface attacks, while Enterprise sustained additional damage that would require extensive repairs. American carrier strength in the Pacific had been reduced to a single operational flat top, exactly the situation Yamamoto had sought to create through the Midway operation. Japanese forces maintained control over the Solomon Islands approaches, and American offensive operations appeared stalled by lack of carrier aviation support. What Yamamoto's intelligence staff failed to detect was that Essex had already been launched at Newport News in July 1942, 4 months ahead of revised projections and nearly 18 months earlier than original construction schedules had indicated. The massive carrier was completing fitting out and sea trials, using accelerated procedures that prioritized getting the vessel operational over adherence to peacetime testing standards. By December, Essex would join the Pacific Fleet as the first of a carrier class that would eventually number 24 vessels. The transformation of carrier construction from specialized craft to mass production enterprise extended beyond the Essex class to include dozens of escort carriers built using Kaiser's revolutionary techniques. These smaller vessels, constructed on merchant ship hulls, lacked fleet carrier speed and aircraft capacity, but could be produced in quantities that allowed America to deploy carrier aviation across multiple theaters simultaneously. The first escort carriers entered service in mid-1942, providing crucial convoy protection and supporting amphibious operations that had previously operated without air cover. Commander Minoru Genda, one of Japan's most experienced carrier aviation officers, reviewed intelligence reports about American carrier construction in late 1942 with growing skepticism about the numbers being reported. American propaganda claimed multiple carriers under construction using revolutionary building techniques that would launch vessels at unprecedented rates. Genda dismissed these claims as psychological warfare, noting that carrier construction required specialized facilities and skilled workers that could not be rapidly expanded even by nations with America's industrial capacity. The intelligence assessments Genda relied upon reflected Japanese naval architecture's conventional wisdom about carrier construction complexity. Fleet carriers displaced over 30,000 tons, required propulsion systems capable of speeds exceeding 30 knots, and needed specialized facilities for constructing armored flight decks capable of sustaining repeated aircraft launches and recoveries. Japanese shipyards had refined these construction techniques over decades, achieving efficiency that had launched Shokaku and Zuikaku in under 3 years. The idea that American yards could significantly exceed this timeline seemed implausible. Essex arrived at Pearl Harbor in May 1943, just 17 months after her keel had been laid at Newport News. Her arrival shocked Pacific Fleet officers who had not anticipated receiving carrier reinforcements for months. The massive vessel embodied design improvements that incorporated lessons from Midway and Coral Sea, including enhanced anti-aircraft batteries, improved damage control systems, and expanded aviation fuel storage that allowed sustained operations without frequent replenishment. Admiral Nimitz toured Essex shortly after her arrival, noting with satisfaction that her aircraft capacity exceeded Yorktown's by nearly 40%, while her improved design incorporated features that would make her more survivable in combat. More significantly, Nimitz's staff briefed him on production schedules, showing that Essex would be followed by 8 additional fleet carriers entering service before the end of 1944, numbers that would give America decisive carrier superiority throughout the Pacific. The intelligence implications were staggering. In 18 months, American shipyards had transformed carrier construction from a specialized craft, requiring 3 to 4 years, into a mass production enterprise that launched fleet carriers faster than Japan could train replacement air groups for carriers lost at Midway. The 4 carriers that Japanese intelligence had counted before Pearl Harbor were multiplying into fleets that would outnumber Japan's carrier force by ratios that made the pre-war strength comparisons seem quaint. Japanese reconnaissance detected Essex during her initial Pacific operations near the Gilbert Islands in November 1943, confirming for the first time that American carrier production had indeed accelerated beyond Japanese intelligence projections. The massive vessel's appearance in combat operations forced Japanese naval planners to revise their strategic assessments about American carrier availability and accept that their assumptions about carrier construction timelines had been fundamentally wrong. Admiral Minachi Koga, who had inherited command of the combined fleet following Yamamoto's death, convened emergency planning sessions to reassess Japanese naval strategy in light of confirmed reports about American carrier production. Intelligence now indicated that America would operate at least 8 fleet carriers by mid-1944, numbers that would give American forces carrier superiority sufficient to support simultaneous offensive operations across multiple Pacific theaters. The strategic implications extended beyond simple carrier counts to include industrial capacity comparisons that revealed Japan's fundamental disadvantage in any prolonged war. American shipyards had not just accelerated carrier construction, they had transformed the entire process into an assembly line enterprise that could sustain production rates indefinitely. Japanese shipyards continued building carriers using traditional methods that prioritized individual vessel quality over rapid mass production, an approach that could not match American output regardless of worker skill or dedication. Essex's sister ships began arriving in the Pacific at intervals that confirmed the Industrial Revolution transforming American naval construction. Lexington joined the fleet in February 1944, followed by Bunker Hill, Yorktown, and Intrepid over subsequent months. Each carrier brought improvements incorporated from combat experience with previous vessels, creating a continuous cycle of design refinement that enhanced capability while maintaining production speed. The escort carrier program produced vessels at even more impressive rates. By mid-1944, America operated over 40 escort carriers providing convoy protection, anti-submarine patrols, and amphibious operation support across both Atlantic and Pacific theaters. These smaller carriers lacked fleet carrier capabilities, but their numbers allowed America to deploy carrier aviation anywhere. Naval forces operated, creating tactical flexibility that Japanese forces could not match. Japanese naval aviation faced a different constraint that industrial capacity alone could not address. Trained pilots required months of instruction and hundreds of flying hours to develop the skills necessary for carrier operations. Japan's pre-war training programs had produced highly skilled aviators, but combat losses since Pearl Harbor had depleted this pool of experienced pilots faster than training programs could replace them. The Turkey shoot at the Philippine Sea would demonstrate that Japan lacked sufficient trained aviators to effectively operate even the carriers they still possessed. The industrial transformation that produced fleet carriers in 17 months proved equally applicable to aircraft production. American factories launched fighters, dive bombers, and torpedo planes at rates that allowed immediate replacement of combat losses, while expanding aircraft inventory to equip new carriers entering service. By mid-1944, American carrier air groups averaged 90 aircraft per fleet carrier, compared to Japanese carriers that operated with 50 to 60 planes when fully equipped. Admiral Jizaburo Ozawa commanded Japan's remaining carrier force during the Battle of the Philippine Sea in June 1944, aware that his air groups were filled with partially trained pilots facing American aviators with extensive combat experience. The 9 Japanese carriers under Ozawa's command should have presented formidable opposition to American forces, but pilot quality differences eliminated any tactical advantages Japanese forces might have gained through numerical parity. The engagement that American pilots would nickname the Great Marianas Turkey Shoot saw Japanese carrier aviation destroyed as an effective fighting force through a combination of American tactical superiority and overwhelming numerical Turkey advantages. 15 American fleet carriers deployed over 1,300 aircraft against Ozawa's force, launching coordinated strikes that overwhelmed Japanese defenses through sheer weight of numbers. Japanese fighters attempting to intercept American strikes faced opponents who outnumbered them by ratios that made effective defense impossible. Ozawa's force lost 3 carriers and over 600 aircraft in exchanges that cost American forces 30 aircraft and minor damage to several vessels. The battle demonstrated that American carrier production had created not just numerical superiority, but a tactical flexibility that allowed American commanders to sustain losses that would have crippled Japanese forces while maintaining offensive momentum through immediate replacement of damaged or destroyed aircraft. The industrial statistics compiled by American production authorities in mid-1944 revealed the extent to which carrier construction had been transformed into a mass production enterprise. 24 Essex-class carriers would eventually be commissioned, along with 9 Independence-class light carriers built on cruiser hulls and over 100 escort carriers constructed using merchant ship designs. The total represented carrier aviation capacity that exceeded anything previously contemplated in naval planning, creating force structures that treated individual carriers as expendable weapons rather than irreplaceable strategic assets. Japanese naval intelligence finally acknowledged the scale of American carrier production in reports compiled after the Philippine Sea engagement. The 4 carriers counted before Pearl Harbor had multiplied to over 30, fleet and light carriers operating in the Pacific alone by mid-1944, with additional vessels entering service at intervals of less than 2 months. The production rates defied Japanese understanding of carrier construction complexity, suggesting that American industry had fundamentally reimagined how these vessels could be built. Admiral Toyoda reviewed the intelligence summaries with the grim recognition that Japan could not counter American carrier superiority through tactical excellence or strategic maneuvering. American forces could afford to lose entire carrier task forces while maintaining offensive operations through replacement vessels that arrived faster than Japanese forces could inflict losses. The war had become an industrial contest that Japan had lost before the first shots were fired at Pearl Harbor. The final statistics tell a story of industrial transformation that reshaped naval warfare. In the 18 months following Midway, American shipyards commissioned 14 Essex-class fleet carriers, 9 light carriers, and 37 escort carriers. Production continued through 1945, at rates that added fleet carriers to American strength every 6 to 8 weeks. Japanese shipyards commissioned 3 fleet carriers during the same period, vessels that lacked trained air groups to operate from their flight decks. The 4 carriers that Japanese intelligence counted in June 1942 represented not America's maximum strength, but merely the peacetime fleet of a nation whose industrial capacity had not yet fully engaged with war's demands. Once aroused, that capacity produced carriers at rates that made pre-war planning assumptions obsolete, proving that counting existing forces reveals nothing about industrial nations' ability to build new ones. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.